Hello, everyone, and welcome to Rules for Differentiation A. In the last unit, we talked about what it meant for something to be a limit and how that corresponded to our understanding of derivatives. So let's just say it one more time. If you want, you can skip ahead, but I really want you to understand this concept that a curve, unlike a line, has different slopes the whole way. And a derivative is a formula that tells you the slope at any point along the curve. So if I told you that the curve was y is equal to x cubed minus 3x squared plus 1, and then I told you that the derivative, this is the formula, the notation for derivative, was 3x squared minus 6x, that means anywhere along this curve, you could plug in the x value where you wanted to know the slope, and that would tell you. And we did that by limits. We found 2 points along the curve, and then one we called x and f of x, and one we called x plus h, although this formula uses delta x. You have to get accustomed to being able to do both, times x plus delta x. And then we found the slope. So it's really this x plus delta x minus x. So here's your y2 minus y1 over your x2 minus your x1. And as that delta x, as that distance, that change of x between them, the change between them became 0, you were actually finding the slope at a point. And we call that a derivative. This next unit will do all the rules for derivatives because we're not going to keep doing the limit. The limit is the foundational concept, but there's a lot of mechanics for derivatives, and that's what we're going to spend this unit doing. When we do that, we're going to use a lot of different notations. A lot of people like y prime. It's like using y instead of f of x. It's very easy. But sometimes, just like sometimes we like f of x versus y, we like f prime of x versus y. We're also going to use dy dx. That d is for delta, not derivative. It's really delta y over delta x, which is the formula for slope, okay? Now, you might even see it as d of f of x. Remember, f of x is the same as y, dx. So really, these two are the same, but one's a y and one's an f of x. And when you see that, sometimes they actually put the f of x out front. They move it from the numerator just to out front, which means the same thing. So all these things mean the exact same thing, but they all have different purposes. So we're going to go through all the rules. The first one is the constant rule, and that says that if you're taking the derivative of, so remember parentheses means of, the derivative of a constant function, what is the answer going to be? Think about that. Derivative means slope. So if I have a constant function like y is equal to 5, what is the slope? There's no formula needed. The slope, y prime, is going to be 0. So the rule is that the derivative of a constant is 0. This dx on the bottom means with respect to. So eventually, we are in single variable calculus. Eventually, you'll be in multivariable calculus, and then you'll get a lot more complicated. But we're just going to work with respect to x for right now. The power rule says that if you're taking the derivative with respect to x of x to the n, that you can bring that power down in front, and then you can reduce the power of the x by 1. So let's notice that I've used all different notations. I'm just trying to get you used to them. The actual rule is a snap. So if you understand this concept, by all means, fill them out real quick and then just look at the answers. If y is equal to x squared, then the derivative, by which we denote y prime, is 2x. I bring the 2 out in front and I make it x to the first, but nobody writes that. We would just write y prime is equal to 2x. Different notation. F of x, I reply with f prime of x. Try and keep the notation the same. 3x squared. I bring the 3 down, and now I have x to the second. This is so much easier than using limits, right? Okay, here's the hard one. Notice that in these, they give you a function, you give them the derivative. They give you a function, you give them the derivative. On this one, you're jumping straight to the answer because it's saying the derivative of x to the fourth with respect to x is 4x cubed. It's not a two-step like it is for the ones above it. A little bit different. Letter D, y prime is equal to 13x to the 12. I'm bringing the 13 down, and now I'm making it x to the 12. Again, this one doesn't get its own answer separately. It just is. The derivative of x to the 79 is 79x to the 78. I chose a weird number so you'd see it keeps applying. So the constant multiple rule is extremely similar. It's saying that if you're taking the derivative with respect to x of something that has a constant before the u, then the derivative would be the constant times the derivative of u. So in other words, the constant just stays there. You would still just do the derivative of u. So they want you to think of this as the constant just stays there, and then you do the derivative of this thing. So u is used a lot in calculus. So this would be your u. And the derivative of that piece with respect to x is 5x to the fourth. But nobody does this step. Everybody just does 5 times 7 is 35x to the fourth. But part of my goal this year is for you to understand notation. So I want you to be able to look at something like this and say, oh, I understand what that notation means. So it means if you're taking the derivative of a constant times something, so u is just something, then you just leave the constant out and just do the derivative of the u. But nobody does that. Y prime is equal to, do the negative 3 times the 4 is negative 12, and then drop the power by 1. I think we need a smiley face. Letter C, f prime of x is equal to 4 times 2 is 8, drop the power by 1, x to the first. This one is that slightly funkier notation, so we're going to jump straight to the answer. We don't have to write an f prime of x. The derivative of 2/3 x to the third is 2x squared. It just is. Now, honestly, you do not need to know the sum or difference rule. If I just said to you, going straight to A, what is the derivative? You would say, why is this in a special section? This is completely obvious. It is. There's no plus. There's so much about calculus that's completely obvious. And when you get to college and you see funky rules, just don't even worry about it. But here's what the rule is. It's saying if you have the derivative of something, u, here comes that u again, plus v. All right, I just want to be clear that if I was writing calculus, I wouldn't have my two variables be u and v. They're very similar for a sloppy writer. So I will always do a little bit of a cursive u and then a really straight v to try and keep them clear. But I don't make this stuff up. So the derivative of u plus v means you can do the derivative of u And you can do the derivative of v separate, which honestly you would have done intuitively. So go ahead and crank those out. I'm just going to write up the answers. Pause the video, try it on your own. Or be lazy and let me do all the work for you. Oh, I forgot my prime on that one. Okay, take a minute and check those. I just want to say at some point, I'm going to make a mistake on one of these videos. Please let me know so I can go back and edit it. Okay, higher order derivatives. So the first derivative of this function is 3x squared minus 10x. There is something called a second derivative. The second derivative is 6x minus 10. And the third derivative is 6. If you were to do a fourth derivative, it would just be 0. You can keep going with derivatives. And they do have meaning, which we'll discuss at a later date. The first one, you know that y prime means the slope of the curve at a given point. Eventually, you'll have to know what the second derivative means and the third derivative means. But for right now, I just want you to see that you can keep doing them. Y prime is equal to 2x plus 1. If I take the derivative again, I'm just looking at this function now, and I get 2. And then when I do the third derivative, I just get 0. Now this next one introduces something different for us. You can't take the derivative of a top and the derivative of a bottom. So when they give you all these rules, there is a reason for them. There's a reason for the power rule and the constant multiple rule and the sum and difference rule, because they want you to know what you're allowed to do and what you're not. And what you're not allowed to do is you are not allowed to take the derivative of a numerator and a denominator separately. Uh-oh, I'm really getting words that I can't spell. All right, so how do we fix this problem? We're going to change the form. I'm going to change this to y is equal to x over x plus 1 over x. And then I'm going to change that to y is equal to 1 plus, look at me being tricky, x to the negative 1. Now it's a problem that I can take the derivative of. Y prime is 0, the derivative of 1 is 0, and this one's going to be minus 1 x to the, now you think about that, what do you get when you subtract 1? Negative 2. And then I'm going to do it again, plus 2 x to the negative 3. And I'm going to do it again, and I get negative 6x to the negative 4. So super interesting problem, how it changes when you do that, okay? So that's a basic introduction to the rules of derivatives. We will actually learn how to do harder ones that can't be simplified in the next video. But today we're going to stop and do word applications. The entire year, the word applications are what are really important. These are just the tools, the skill set to get there. So our first one says, what is the equation of the line? Oh, I'm going to stop reading right there. The question is, what is the equation of the line? I am literally going to stop and box my answer now. Because they want to know the equation of a line, I'm going to go like this. I already know that this is what I want. I'm going to find the slope, and I'm going to find 1 point, right? And if I can just find those two things, then I've got the answer. What is the equation of the line tangent to the curve at? Heck yeah, they just gave me the point, okay? So really, all I need to do is find the slope. So we have a formula for that. If you want to know the slope, you use the derivative formula. So the derivative is 4x. Now, here's where the different formats come in. This is not useful to me. This is useful to me. Why? Because now I can say, I want to know the slope where? Where do you want to know the slope? You want to know the slope at -1, 2. Which of those two numbers is important? The x. I want to know the slope when the x is -1, and I get -4. That's the number that's going to go in here. Now, some of you are getting this right away, but I want you to really understand it. So I'm just going to take just a second and draw it. So normally, let's see, -1, 2. So this is a parabola. Instead of 1, 1, it's got a 2 in front, so it's going to be 1, 2. So it's a pretty steep parabola. And they're saying, what is the equation of the line tangent to the curve at that point? So I'm trying to find the equation of this line. I need to know a point, which is -1, 2. I already did that. And I need to know the slope. So remember, this formula, the derivative, gives you the formula for the slope at any point x. On this curve. Okay, that is only the formula on this particular curve. So if I was trying to find the slope here, I'd plug in a 1. Right there, the slope is 2. Right here, I'd plug in 0. The slope is 0. All right, there's different slopes all along the way. What's the slope right there? See how there's different slopes? The slope right here is -4, which looks right. By the way, if you wanted to just double it, first of all, you will always make me happy when you graph. Make the graph. And second, look how I can just check this. I feel like it should have a b of maybe, I don't know, 1, 2, 4, 3, somewhere in there. Let's check it. -4x minus 4 plus 2, y is equal to -4x minus 2. All right, not as low down as mine, but I also could have drawn it slightly differently. If I had drawn it like this, I could have made it work. So it's hard to draw a tangent line, but at least it didn't come out positive. I definitely felt like I was in the right vicinity, and that's what it's trying to do. Let's do another one. The line y is equal to 3x plus b is tangent to the curve. Oh, same curve. So let's quick draw it. So 1, 1, 2, 1. Same curve. It's a parabola facing up. And instead of being 0, 0, 1, 1, it's 0, 0, 1, 2 because of that 2 in front. And it says y is equal to 3x plus b is tangent to the curve. This is a much harder problem because they didn't give us as much information, but I can still kind of draw this. I want a slope of 3. 3 is pretty steep. So let's just say I pick a point. I don't actually know if that's the point. And I'm going to draw it because I think that that looks like a slope of 3. I'm trying to draw a line with a slope of 3. So what am I expecting b to be? A negative number for sure. I want to know the point of tangency, which is definitely going to be in quadrant 1. If the point of tangency is not 2 positives, you should be worried. It's got to be in quadrant 1. First of all, the curve has no quadrant 3 or 4 points, but it's also not going to be on this side because that would give you a negative slope. But we want the line y is equal to 3x plus b to be tangent. So here's how we're going to do this. By the way, if you want to stop the video and try and think of this on your own, that would be great, great, great. If you were in school, I would normally put you into groups and force you to puzzle your way through it. So this point has 2 values. This is the interesting thing here. It has one, I'm actually going to change the color so you can kind of follow along there. By the black curve, that point is the point x comma 2x squared, because that point is on this parabola. But that point, at the moment that it's tangent, it's also on the line, but it's also the point x comma 3x plus b. It obeys both equations because whatever the x value is, it's on the parabola, so it's got a y value of 2x squared, but it's also on the line. So whatever x is, it has a y value of 3x plus b. This is good news because now I know something. Now I know that 2x squared is equal to 3x plus b. So there's going to be 2 major components to this problem. One is realizing that the point is on both the line and the curve. The point is on the line and the curve. The second big thing is that at that point, the slope is the same. At the point, the point, that didn't make sense. At that point, the slope is the same. So let's look at it again in terms of black and blue. The blue line, we know the slope is 3. The slope of the line is 3. But what's the slope of the curve at that point? It's also 3, but we don't actually know the x value, but we can find a formula for it. F prime of x is 4x. That tells me the slope anywhere. So 4x equals 3 means I can find, using this formula, the x value where the slope is 3. So 4x is equal to 3, x is equal to 3/4. So the 2 parts to this problem is realizing that the point is the same for the line and the curve, and the slope is the same for the line and the curve. And now that I have that, I know what point it happens at, so I'm halfway to my answer. Find the point of tangency. So B is, and point of tangency. I'm just going to start filling in my answer when I find things. So I know it's 3/4 comma something. It's going to be my answer. So I can find B now because I can fill this in. 3/4 squared is equal to 3 times 3/4. And if you're like, yeah, I can finish this from here, then go for it and skip ahead on the video. I'm always okay with that. For people that are needing a little extra help when you're doing fractions, times a whole number, change the whole number to a fraction. And then multiply fractions straight across the top. So this becomes 18 over 16. And this side becomes 9 over 4 plus b. 9 over 4 plus b, which isn't completely helpful. So I'm going to reduce this to 9/8. And this one, to make it into eighths, I'm going to make it 18/8. So when I subtract 18/8 from both sides, I get b is equal to -9/8. And that makes sense. It is pretty close, right? 1 and maybe just a little bit. I did this graph better. So then the last question is, how do we find the y value? So this is a phrase I'm going to repeat a lot. To find a y value, use a y equation. To find a y value, use a y equation. I know that sounds really obvious, but these problems are just so long and hard that people get lost in them. So where do I have a y equation? I have two of them. I have y is equal to 3x plus b, and I have y is equal to 2x squared. So I'm going to use y is equal to 2x squared because it has less things going on. And what if I got b wrong? I don't want to use b to find y. So y is equal to 2 times my x value is 3/4 squared. Again, I'm changing this to a fraction. And then instead, just to keep showing you different math, instead of multiplying first and then reducing, you can cancel. That becomes 1/8. So y is equal to 9/8. If you skipped ahead and got it right, good for you. Number 3, find all the points on the curve y is equal to 2x cubed minus 3x squared minus 12x plus 20, where the tangent is parallel to the x-axis. So what you're going to find this here is that there's not going to be 2 questions in a row. It's not algebra 1 or algebra 2. It's not a class where I do 1, you do 10 like it. Every problem is different. You're always going to have to be thinking. So I don't know what this graph looks like exactly, except it's cubic, it's going up, it crosses at 20. So I guess I'll count by tens in order to make my graph look good. But what I want to know is where the tangent line, so there's a tangent line here, tangent line here, tangent line here. You don't want to keep drawing the whole line, it'll get really cluttered. But there's tangent lines all over this graph. I don't want any of those. I want to know where the tangent line is parallel to the x-axis. So this one actually came out a little bit on the x-axis. I just kind of drew it. And this one's right there. There's actually going to be 2 answers. So again, I personally make my box. It helps me keep my focus to say I'm looking for 2 points. What is special about these 2 points? At that moment, the slope is 0. All your algebra, everything's coming together. And we worked so hard to learn what parallel meant and where the x-axis is. And now parallel to the x-axis means the slope is 0. Slope is 0. The formula for the slope is the derivative. Y prime is 6x squared minus 6x minus 12. Normally, the slope or the formula is used to plug in an x and say, I want to know the slope at 2 or I want to know the slope at 10. But this time, I don't want to know the slope at a certain point. I want to know the point that creates 0 for a slope. And again, just to make you excited about all your hard work for the last 3 years, set it equal to 0 and factor. What kind of factoring should we always do first? Factor out. Okay. Set it equal to 0 and factor. I just have to write it. I'm so excited. Set it equal to 0 and factor. Factor out first. And because I think some people are only breezing through the video and not listening. So I'll write extra. X minus 2 times x plus 1. There are still people, even in their senior year, that accidentally do something with this. But keep in mind, there are 3 things being multiplied together, and the 0 is the answer. One of the 3 things is 0. It's not the 6. Okay? So sometimes people accidentally add this answer, but that is wrong. Don't do that. Okay. But if x is 2, that'll make this factor 0, which will make the whole thing 0. And if x is -1, that'll make this factor 0, which will make the whole thing 0. If x is 0, you would have 6 times -2 times 1. That is not equal to 0, okay? That's not an answer. The 6 does not affect the problem at all. So I know that if x is equal to 2, this is going to have a horizontal tangent. It's going to be parallel to the x-axis. And if it's -1. How do I find a y value? To find a y value, use the y equation. So every year, somebody, even after I write this, somebody is going to plug 2 back into the derivative equation. It's not, you don't want to know the slope. You want to know the point. So if you want to know the y value, use the y equation. So when I plug 2 into this equation, I'm going to let you do that math yourself. But you do get 0. And if you plug -1 back into this equation, you'll get 27. Why is this so valuable? Because now I can actually draw the real graph. Now I can say, oh, at 2, 0, and at, oh, I'm not going to draw that. That's not 2, 0. That's -2, 0. At 2, 0, and at -127, -127. So I actually know a lot about this graph now. Okay, which actually makes a lot of sense, right? Because right there, isn't the y-intercept 20? So, but between the y-intercept, the peaks, the max, and the min, you can actually draw a really nice graph, even though normally we used to have to find the x-intercept to make a nice graph. Okay, there are 3 more. I'm going to say this every time. The more of these you can do on your own, the better. But I'm going to do all 3 of them for you. On number 4, it says the curve y is equal to x squared plus c is to be tangent to the line y is equal to x. The key to almost all these problems is to make a sketch. It'll help you so much. You might be thinking, well, I know that's a parabola facing up, but I don't know what c is. So let's start by sketching what we do know. We do know what the line y is equal to x looks like. So I'm going to plot the point 1, 1, or 0, 0, 1, 1, 2, 2. And now I have the line y is equal to x. Now, they want a curve x squared plus c to be tangent to this line. So I'm going to try to draw a parabola that just barely touches it. Sometimes kids draw the parabola through 0, but notice that won't make it tangent. It's going to have to move up a little bit. So maybe like that. Oh, I moved it up too high. One more try. Close enough. So it's tangent right there. It also, now that I've made the sketch, I have some concept of what c is. It can't be too high. It's definitely going to be a number between 0 and 1. So like a problem that we did just a little while ago, this point has 2 names. On the line, if you knew x, you'd know y, because it's on the line y is equal to x. Every point is 1, 1, 2, 2, 3, 3. But in terms of the green, if you knew x, then y would be x squared plus c. Putting these 2 pieces together, x is equal to x squared plus c. So just like the last problem, not the very last, but a couple problems ago, identifying the point as being something that's on both the line and the parabola gives you the first in a system of equations. The second thing, so this is all about the point. The second thing is going to be all about the slope. The slope of the line is 1. The slope of the parabola obeys the rule 2x because y prime is 2x using the rules of derivatives we just learned. So if I knew, because c is a constant, so it goes away. So if I knew what x value that was, I could tell you the slope. But instead, I'm going to do it backwards. I'm going to say, I want to know the x value when the slope is 1. So I can put these two together. Let me just write parabola. Parabola slope at any point x. So specifically, to have a slope of 1, x would have to equal 1/2. Now that I know that x is 1/2, I can put these two together and say 1/2 is equal to 1/2 squared plus c. That gives us 1/2 is equal to 1/4 plus c. Subtract 1/4 from both sides. You should change this to 2/4 so that you can do the subtraction. And c is equal to 1/4. That didn't come out good at all. C is equal to 1/4. And that's your answer, because the question asked you to find C. On number 5, it says you have a curve and another curve tangent to each other. So not just a line and a curve this time. What are we going to do first? Come on, say it to yourself. Make a sketch. You might be thinking, I don't know what it looks like. I don't know A, I don't know B. This is where all of your hard work in pre-calculus is going to pay off. We're going to graph what we do know. So I do know that this is an upward parabola. I know, okay, that's it. On this one, though, you actually know a lot more than you think you do. First, let's rearrange it. Negative x squared plus cx. So I know that it's a downward parabola. And watch this. If you factor out the negative x, you'll get x minus c. So now you know the intercepts. Remember, that's how we always find the intercepts, is by factoring and setting it equal to 0. So either x is equal to 0 or x minus c is equal to 0. If you want, you can say negative x is equal to 0, but in the end, it's going to be x is equal to 0 or x is equal to c. So this is great. Now I know that 0 and c are where this downward parabola is going to go. I missed. But I didn't even get to the third piece of information yet. They're tangent at the point 1, 0. Well, if 1, 0 is on this parabola, this must be the point 1, 0. So now I know what c is. So c must be equal to 1 because I already know the intercepts. And if you're thinking, I never would have thought of that, that's okay. That's what we have this whole year to work on, is getting you to think at a much higher level than you did in previous years. Now, for this one, I still don't know a lot about it, except I know that it faces up and it's tangent to this one at this point. So I can't just draw it anywhere. I have to draw it tangent, which means it's going to look like this. It's just barely going to be touching. And remember, always go back to the point. I know that 1, 0 is on y is equal to x squared plus ax plus b. So you can plug it in. So 0 is y, x is 1, and I can simplify this. 0 is equal to 1 plus a plus b. So I have a little equation here that might help me. So I've already found c. I'm going to box that answer. But I still need to find a and b. Well, we haven't used anything about slope yet. You know we're going to need to find something about slope. So this is going to be the second key. You still have two unknowns, so you need a second equation. So there's two graphs. For the green one, y is equal to x squared plus ax plus b. The formula for the slope is 2x plus a. Now that's not a good way of writing it because I need to actually plug something in here. I want to know the slope at 1 because that's that point of tangency. At 1, the slope is 2 plus a because if x is 1, you just get 2. Now let's go to my black parabola. Y is equal to negative x squared plus x. Remember, I know that c is equal to 1. I've already found that, so I can use that knowledge. Y prime is negative 2x plus 1. Did it again. That's not a helpful form. I'm trying to show you that sometimes y prime is nice, but sometimes you really need the format f prime of x. That's how it's pronounced, f prime of x. And I want that because I want to say, what is the slope at 1? That's literally what this means. What is the slope at 1? And when x is 1, you get negative 2 plus 1, which is negative 1. So now I can put these two pieces together and 2a, because at that moment they both have the same slope. They're tangent to each other. So they share a common angle right there. So at 1, the slope of the green parabola is 2 plus a, and at 1, the slope of the black parabola is negative 1. So now I know that a must be negative 3 by subtracting 2 on both sides. I got my second answer. To get the third one, use this equation. 0 is equal to 1 plus a plus b. But now that I know that a is negative 3, I can finish this up. B is equal to 2. Let's just make sure that's what they were asking for. Right, find the values of A, B, and C. All right, we just have one more here. What are you going to do first? Come on, make me happy. You're going to make a sketch. So remember, a cubic function has this. I'm going to write it again. I want you to see it. Make a sketch. Remember that a cubic function generally has this shape. And the way we did it last year in pre-calculus was to try to find as many of the zeros as we could. If we can find the zeros and a y-intercept, we can actually make a pretty nice shape. Well, we do know the y-intercept. The y-intercept is going to be 0, 0. And we can find the x-intercepts by factoring and then setting that equal to 0 to find the x-intercepts. So 0 is equal to x times x minus 1 times x plus 1 means that the x-intercepts are 0, 0, 1, 0, and negative 1, 0. So now you can make a really great sketch. 0, 0, 1, 0, negative 1, 0. And it goes to the point, negative 1, 0, which you already know. That didn't give us anything else. Good. So it goes up like this. I don't know how high or low it goes. Doesn't really matter. I'm trying to make a decent sketch. And now I'm going to draw a line tangent to the curve at that point. So here's my tangent line. It's going to be very steep. Where else does the line intersect the curve? Wow, it doesn't look like it intersects. They almost look parallel. So if I keep drawing this, and if I keep drawing this, They will eventually intersect. So my sketch isn't perfect. So I actually am going to just change it only so that you guys can see it a little better. I'm going to stick with the basic sketch, but I'm not going to make it so steep a parabola. That way we can see where they intersect. I really want you to be able to see that. So it was blue, meaning I'm just going to go like that. Okay. And then this tangent line here, because this isn't so steep, I can draw it a little bit more like that. And now we'll be able to see that they do eventually intersect. They would have on the other picture too, but it would have been hard to see. So I'm trying to find this point. Now think back to pre-calc. How do we always find the point of intersection? We always find the point of intersection by knowing the equations of the two graphs. Well, we already know the blue one, so I need the green one. It's going to be y is equal to slope times x minus 1 minus a minus 1 plus 0. I just need to know the slope. And then I'll have the green line and the blue curve, and I can find their point of intersection. All right, so how do I find the slope of the line? Well, at that moment, the derivative, which a derivative is a formula for the slope, don't worry, I'll eventually stop saying it. Formula for the slope is 3x squared minus 1. That's going to tell me the slope anywhere on the curve. You can see it keeps changing. It's steep and positive, it's 0, it's negative, it's 0, it's positive. I want to know what it is right there. Okay? So I'm going to plug in -1. The slope, this means the slope of y is equal to x cubed minus x at -1. That's literally, that entire sentence is in this little expression, is 3 times -1 squared minus 1, which is 2. Does it look like a slope of 2? Yeah, probably on my first drawing it was a little better, it was a little steeper. But I was trying not to go too high. All right, so the slope is 2. Well, since it's the tangent line, I can borrow that slope. This slope is 2. So the equation of the line is 2x plus 2. The equation of the parabola of the cubic function is x cubed minus x. I'm going to put both of those together. Y is equal to 2x plus 2. Y is equal to x cubed minus x gives me 2x plus 2 is equal to x cubed minus x. So interestingly, you can't do this by hand. We can set it equal to 0, x cubed minus 3x plus 2, but it's not factorable. And since it's not factorable, you can either hunt for the zeros using synthetic substitution, good luck with that, or you can do this on your graphing calculator. So you have two choices. You can either plug y1 and y2 in your graphing calculator and use the intersect feature, or you can just plug this one in as y1 and find where it crosses 0. So it's kind of up to you. I will do it both ways. Then you can skip to the video and only watch it if you want to. So you take out your graphing calculator and you realize that you've found the equation of the line, which is 2x plus 2. So you type that in as either y1 or y2. The original equation was x cubed minus x. Just ignore y3 for now. And notice that it's not highlighted, so it won't graph. And I hit graph. This is a fantastic way to check your work. Remember, the original problem was the blue curve, and the question said that it it had a tangent at -1, 0, and then the question asked, where else does it intersect the curve? So now you can really clearly see that it intersects again up there. How do we find that point of intersection? With our intersect button. Second calc. Intersect, you can either scroll down or you can just hit the number 5 and it'll go right to it. It'll ask you what the first curve is. They're already saying it's the blue one. If yours isn't color-coded, it still says it at the top there. And then it says, is this the second curve? And you just hit enter again. Would you like to make a guess? I never guess. And there you go. It gave you the point of intersection, 2, 6. And that was the question, was where else does the line intersect the curve? Now, it's possible that you started to do this by solving, and instead of going back to this step, you might have gotten stuck at the step x cubed minus 3x minus 2 is equal to 0. If you got stuck at that step, you can always use your graphing calculator. So forget that we ever actually did it this way. Notice I'm untoggling these so I don't see them anymore. And I am highlighting this one. So if the question is, where does that function equal 0? Then it's equal to 0. It looks like at -1 and at 2. You have a couple choices to confirm that. One is to hit calculate and actually ask it to find the zeros. You'll have to do something to the left. So we're not really to the left of it. It looks like it's at -1. So I'm going to say -2, right bound 0. And look what that did. That gave me a range. You're saying, I think the 0 is at -1, but I'm pretty sure it's between -2 and 0. You hit enter, and it did it. Found that it was at -1. Now, we already knew that one of the answers was -1. That was the point of tangency. You really need this one. Well, a second way to confirm, I mean, it looks like 2, but it could be 2.001. You can't always be sure, is to go to the table. In the table, now you can clearly see that when x is 2, you get 0. So if instead of actually graphing the two functions and seeing where they intersect, you tried to solve and got to y3 and you set that equal to 0, that's another way to solve it. So two very different systems, and sometimes people get them confused. You might still be confused, and you're welcome to ask me about that in class. All right, that's it for this lesson. Have a great day.